Now let's take a look at the next four. In this chapter, we also delve more into this concept called mirror images, right? Since we know that smooth surface can give us a reflection, right? Let's take a look at what are some properties of reflected image. First and foremost, we must remember that images are never real, so they are always virtual. A virtual, which means that you can never form it on a screen. Okay, so let's say that when you look at the reflection in the mirror, right, there's actually nothing behind the mirror. Although it looks like there's a reflection inside the mirror, right? But there's clearly nothing that's behind it except for the wall, right? So that's what we call virtual images. They cannot form on the screen. Okay? Secondly, we must always remember that mirrors are always providing us with upright images. That means if you're standing upright, the mirror should give you the same image. At the same time, mirrors always result in laterally inverted images. That means your left and right will switch. So, for instance, if you raise your right hand in front of the mirror will look like it is raising its left hand. And that's how the mirror and the properties of it work. You'll learn more about this if you move on to physics in upper secondary. Now, let's talk about the tiny differences in terms of the type of mirror. Now, if you use a plain mirror, that's a flat mirror. That means it's fully horizontal, right? So the light rays that is reflected will give off a certain type of image. But there's also other mirrors, which are what we call convex mirror, as well as concave mirror, right? If you recall, to understand what concave and convex are, you can imagine that you have a spoon, right? So on the spoon itself, there's two different sides. One is the side that is dented inwards, one is the side that's dented outwards. Right? Concave will refer to something like this part. That means there's a caving in. Convex will refer to something like this part, which means that it's bulging out. Okay? So if you have a convex mirror, when light rays hits it and reflects off, right, you'll see an image that is actually smaller in size, and you'll also see a larger field of view, which means that you'll see more things. Right? This is the reason why we use convex mirror for areas like corner mirror, like when you're crossing the road, right? Or you're walking past certain areas of the blocks. You might see these big mirrors that's used to show you the blind spots that's maybe next to the corner. Right? So it gives you a bigger view, but the objects will look smaller. Concave mirror, on the other hand, it provides you with a larger size image, but a smaller field of view. That means you are sort of zooming in, looking at a specific spot. And that's why we use it in the dentist mirror. Because the dentist mirror that they use, right, is used to magnify certain areas of your teeth, right, so that they can see what's the issue with it. So they want it to be as large as possible, the images. Now, the normal mirrors that we come across in our day-to-day life, the plain mirror that we use at home or in the toilet, right, they always produce images of the same size, and the images are always same distance from the mirror, which means that you will not see more than what the mirror can reflect off, right? And the objects that you see will be as far away from the mirror, as shown over here, as far away from the mirror as you are from the mirror, right? So the distance will be accurate to that. Right? So it's different from your convex and concave mirror. The next concept that we learn about is the reflection of light. Now, reflection is not an easy concept. Okay, so reflection actually says that when light passes from one medium to another, its speed will change. Okay? When the speed change, it will result in a change in the direction, which means that light will bend. Right? Light will bend. So, but this is given that it must travel from one medium to another, which is one type of substance to a different kind. This is because different substances have different optical density. Now, optical density is a type of property that can affect the speed of light. Okay, so let's say, for instance, if you recall, now let's say that there's an object that's in the water over here, represented here by this the laser pointer over here. This is the object. Now, if the object were to reflect off light towards the surface of the water, let's say the light will move upwards in this manner. Okay, once it hits the surface, right, it will leave from water towards air, and we know that water and air are different types of surface, right? So different materials result in different optical density. So now, because of that, the light will actually speed up when it enters air, and it will actually bend away from the normal. So if you look at it, the normal over here, right, this is the angle of what we call refraction. Okay, this angle is actually a lot greater than when the light ray first hit the surface over here. If you compare these two angles, right, the one above the water is much greater than the one inside the water, and that's because the light actually speeds up when it enters air. Right? So from this we can tell that air actually has a lower optical density than water, and because of that, it actually creates something that's very interesting. Because your eyes, right, will receive this light ray that you see over here, and your eyes will not be able to know that the light ray was actually already refracted from the material. So what your eyes and your brain will think is that, oh, the light ray, if it's coming out in this direction, you mean the object must be coming from this direction. And that's why you will seem to identify the object to be slightly higher than where it's supposed to be. But if you recall, we spoke about this when we talked about how fishermen actually hunts for fish using the spears, right? And sometimes it's very hard to aim and to accurately locate the fish, because when you aim, right, you're actually looking at a depth, that means the deepness of the object, right? It's actually what we call the apparent depth, right? Which is not really accurate, because you're actually concerned about the real depth, which is where the object is at. Okay, so refraction can cause an object in the water to look shallower than it's supposed to be. That means it looks a bit higher than where it's supposed to be. It's also important to take note that the larger the optical density, the slower light will move. And when the slower light moves, just like a car that's moving across sand, right, you actually bend more towards the normal. So you start to slow down and move closer towards the normal. So as you see over here, as light passes from air to glass to air, and when the light comes in over here, as it moves from air to glass, right, you actually slow down, because you can see that the angle over here is actually a lot smaller than what it was when it hit the surface. Now when it's leaving from glass towards air, what will happen is that you start to speed up now, because air has a low optical density. And as it speeds up, right, it can move away from the normal line. Alright, so like what I said, refraction is not an easy concept. Do try out the discussion questions, the practice questions, share with your friends, and see if there's anything you're not sure, then you can come and clarify with me. Now the seventh concept in this chapter, okay, this is quite a big chapter, is that we need to understand that light actually consists of multiple colors. Now white light, which we are very used to, is basically a light that we see on a day-to-day basis. White light actually consists of a spectrum of 7 colors: red, orange, yellow, green, blue, indigo, and violet, right? Or I just call it ROY-GB, okay, as an acronym. So what happens is that, how do we actually realize this? If we do an experiment using what we call a glass prism, right, we can actually result in the refraction of light inside the glass prism, because light goes from the air towards the glass piece, so there'll be refraction. And as it leaves, right, you are actually able to split the light, or rather disperse the light in this manner. So these are what we call diversion light rays. That means they are moving away from a certain point. Okay, so this is diversion. This allows us to identify these 7 colors of white light. Now, if you want to recombine back this white light, you can add in another prism over here, which will cause the 7 colors to converge over here. Now, converge means you will move towards the same spot. Okay, so you converge towards the same spot, and then when it comes off as a white light. Now, this is actually something that we do see in a daily phenomenon, which is through rainbows, right? In the case of a rainbow, each water droplet actually acts like a prism, so that when the white light reaches it, it actually gets dispersed into the 7 different colors, and then it casts a rainbow, a spectrum of rainbow in the sky. So imagine there's a lot of water droplets, right? It allows a lot of little glass prism to split the white light to create what you see over here in terms of a rainbow. Do also take note that, how do we actually see colors? We see colors because objects reflect off light rays into our eyes. So for instance, right, if a white light hits the apple, in this case, right, why do the leaves of the apple appear green, and why do the entire apple appear red? That's because the green light gets reflected off to our eyes, while the red light gets reflected off to our eyes from the apple itself. Right? So remember, the colors that you are seeing now, especially the colors that's around you, for instance, your uniform might be grey in color or beige in color, is because that color is reflected through your eyes. That allows you to see the color of the object. So the leaves reflect the green light, that's why we see as green, but all the other 6 colors of lights, right, are actually absorbed by the leaves. Likewise, the apple reflects the red light, that's why we see as red, while all the other 6 colors are absorbed by the apple. So different object, different types of substance absorbs and reflects different type of light. Okay, and with that, we can actually tell that we can infer that if we were to use a more unique type of light, for example, let's use blue light to shine on this apple, right? This apple will not be able to reflect off this blue light. If it's unable to reflect this blue light, because if you recall, the leaf can only reflect green, the apple can only reflect red. So if it can't reflect anything, right, this will mean that the entire object will appear as black because none of the light rays reaches our eyes. So what we see is, we just see that there's a black structure over there, but we can't determine what exactly is the original color of the object because nothing is being reflected. Because we are only using blue light over here, right? So the entire blue light is being absorbed into the apple object. Last but not least, in this chapter, we talk about the impacts of light. Now, we all know that light brought a lot of benefits to our life. It helped in a lot of technological developments, such as the light bulbs, lamps at home, projector, handphones, etc. But light can also result in problems, especially when it's used too excessively. And that is what we call light pollution, which can affect your mental well-being, your level of attention, and it might also make you feel very, very tired. And for some others, it can cause certain eye issues. Alright, and with that, we have come to the end of this chapter, or rather the end of this video on a quick look on ray model of light. So there's a total of 8 main concepts to take note of, and I hope this gives you some clarity about what you can use for the subsequent activities. Goodbye.